Hi guys, I'm Jose and welcome to this new tutorial in Unity. So in the last tutorial we saw how to create this tetrahedron, going through Rhino, then to Maya, applying some kind of textures that we brought into Unity, and now we have this tetrahedron ready to start working with some of its logic of aggregation, right? So let's go ahead and just create a new script that is going to be called going to be JavaScript tutorial 10. Actually, it's tutorial 11, right? Because number 10 didn't have any script, right? So let's just call it 11. And I'm gonna open that, right? And if you remember in tutorial 9, this is the one that we're gonna be using as a template. So you should have seen the video where we were doing tutorial 9, then tutorial 10, just to do the prefab, and this tetrahedron, and then this one, tutorial 11. So if you look at our main camera had tutorial 9 active and still does, right? So let's look at it. You see we could create this cube still, and that's being done by tutorial 9. So I'm going to turn off that one and I'm going to add tutorial 11, right? This is the one that we're going to be working with, right? So but the first thing I want to do is just select everything, copy, and paste, right? Just make sure that you don't have anything. So we're gonna start from there. We're gonna just like really kind of use exactly the same that we had and do some variation. So I'm gonna save that, and the first thing we need to do, if we do that, you'll see that our tutorial 11 is gonna get a few kind of information that is required. The line is the only one that we don't have to set because it's set automatically, but the first person controller would become the parent of the camera, right? And the new object that we're going to be working with now in this case is going to be tetra, right? So let's add that guy, right? So before we run it, let's change a few things. If you just look through the script, one of the things that we were doing, it's just using an if statement that says if you are hitting an object that is from the type supercube, meaning the cube, do the aggregation, right? And the new instance, we were calling it supercube plus the counter. Also, if the tag was supercube, we would be able to replace that object, right? So let's first change this to tetra, just because and here as well, and here as well, just because we used already the tag tetra for our prefab, right? So this is not the cube, and it's not going to work with the cubes. It's only going to work with tetra, right? So let's save that and see if we're getting any errors and what is happening. So you see that I can just select, I can still project my line over different geometries. And you see that I can click on the geometry and replicate it, and it replicates it in the kind of a default orientation without because we're using the kind of quaternion identity. By the way, I also kind of I'm using this kind of 16:9, but you could say free aspect if you just want to have the full screen, right? So that's something to be aware. It's using the normal of the face to project the other tetrahedron somewhere there, but it's not the right distance. It seems that it's definitely not the right distance. Let's check that again once more. So if we just kind of click there, you see that this tetrahedron is way too far away from this one, right? So that's something we want to just fix. And we need to do some scaling of that vector of the normal, because before we were working with a cube and the cube had one unit. The normal vector that is provided by the raycast is exactly 1 unit, so that was pretty handy. And in this case we have to just work with some different values. So I'm gonna go back here to my script, and what I want to do is just scale the normal, right? So the position, that is this line here, I could start by saying, well, variable normal that we already have is, oops, oh, I pressed something by mistake. So heat variable normal equals heat dot normal. So heat dot normal, and now we're gonna do something to that. We're gonna norm dot normalize, and this is an operation that would make, I mean, actually this is not required, but I'm just making sure that it's going to make the normal size 1. The length of this vector is going to be 1, right? And now we can say normal times equals, and here I have to look what is the distance that I want to give to the vector, right? And if we go to Rhino, this value that we have here is the length from the center to this to the center of the face, right? So it's 0.204124. Let's use that. So let's put our here. So times equals 0.204124, and that's the distance from the center to the center of the face. That's, we had to duplicate that just to get to the center of the object again. So we're going to say times 2, right? And this time we're going to say, so that's good, this is a calculation that we want. And now we want to say, well, use the transform position of the object plus this new normal. So let's say plus nor, right? So that's the very first thing for the position, and let's see if that works. So here we go. And you see that we create another tetrahedron, and this one's definitely closer than the one before. It doesn't have the same orientation, or the orientation that we want, but it is actually pretty tight, and I think that that would be fine, right? Because we can keep on trying that and creating all sorts of, you know, something like a Christmas tree, I don't know. But we definitely need to start dealing with the orientations now, right? So let's look at the orientation. One of the things that we want to do, basically the orientation script requires a bit of info, right? Requires that we understand a specific vector. For instance, when we hit a face, how can we calculate the direction of a face, right? Meaning, if I would be able to collect these 3 points, I could be able to collect the centroid. And the centroid, between the centroid and this edge, or any of the edges, really, will give me the direction, a specific direction of the tetrahedron. And that's something that we actually need. So this is going to become a bit complicated, but we're going to have to just go through it, right? Which is how to kind of collect from the ray, right? The ray we're sending, that it's here, our heat, right? We could start basically collecting the information of the points, creating a centroid, and then starting to use that information for the orientation down here, right? So let's do it very slowly, right? So we're going to start by saying, I'm going to do some space to work here, and I'm going to say variable mesh collider. Sorry, that's not the name of my variable, so let's not just name it like that. It's going to be heat dot collider dot, or as mesh collider, right? So that's going to give us the mesh collider of the object that we're hitting, right? Then we're going to create a variable mesh that is from the type mesh, and that, oh, see, there we go. And this is mesh collider dot shared mesh. There we go. I think that should work. Let's keep checking as we go that we're not running into errors, right? So let's see. That's working fine, right? Because this script, I don't want to just have any errors here, right? So we're gonna do vertices, and this is gonna be mesh dot vertices, and variable triangle equals mesh dot triangles. Right, so these variables is like this one is getting from the object where we hit the mesh collider. This one it's actually creating a variable mesh. It's collecting the mesh information from that mesh collider, right? Then we are kind of from that mesh we're collecting the vertices and the triangles, right? Which is like the face information in this case, right? So we're ready to determine the variable p0. That is going to be our vertices, right? Because this vertices is going to be an array, right? It's going to have more than one vertex inside. We're going to say the vertex triangle, and then hit dot triangle index times 3 plus 0, and actually this is a square bracket because it's part of an array, and this is another square bracket. Really, actually these two are. So what we're getting is, let's go through it slowly. We're getting this vertex is it's an array, right? So we need to say a number, and we want to get a number which is we're gonna go inside the array, the triangle, which is also an array. Let's say 0, it's going to be the first triangle, to 1 or so, it's going to be the second one, and we're going to collect the triangle which we are hitting, the triangle index, right? And that's going to give us the triangle that we're looking for, and we're collecting the vertex, the specific vertex that we need there. So we can do that 3 times to get our P0, P1, and P2, right? And if you want to read more about this script, you can find it in the Unity documentation, just to kind of how to access the individual vertices of the mesh. But the problem is that this triangle, these points that we're getting here, are in the local space, right? These are kind of relative to the center of the object, right? So we need to actually to get the global position of those points, we need to basically do some relation to the matrix of the object. So we're going to say variable hit transform, and this is going to be from the type transform equals hit dot collider dot transform, right? And from this one, what we could do is, I'm going to call these ones differently, variable p0 loc, meaning local, and it's going to be hit transform dot transform point, and this is going to be it's going to just bring this point to the global location, right? So now this point actually has because this is basically a matrix multiplication of a vector and a matrix, I believe. So what it's doing is just picking the points of local space and bringing them to the global space where this hit transform information is being considered, right? So we could do that. And I know this is very confusing, but it works. So let's just roll with it and then try to understand it better, right? So we have the points in local space, the points in global space, right? So we can add some comments here. Points in global space. And the mesh info. And this I'm putting it here because I think that this information it's extremely useful for all sorts of purposes, so it's good to just have it still, as long as we're just gonna work with P0 actually, right? One of the things that we could do is having these 3 points. We're gonna say variable centroid, actually this should have been, because these are global, we should have put the local to these guys here. So these are local and these are gonna be our global objects, right? Sorry about that, I'm just gonna be more clear because local, so these are the local points, these are the global points. So centroid is gonna be, if you think about it, it's like P0 plus P1 plus P2 divided by 3, right? So if we just add, this is the average between these 3 points that are kind of the 3 points of a face, and the centroid of that face is going to be the average of the 3 of them, right? Divided by 3, right? So that's pretty straightforward. And what we need to do now is just use that centroid, the relation between the centroid and the P0 or P1 or any of them, to really kind of build a vector, which is a vector of subtraction to determine the orientation of this face, right? So it's going to be a vector like this, and that vector is going to be really useful for us, right? So let's see. What I'm going to do is just create this instance here, and after, so here we create the instance, right? So after creation, rotate the object, rotate the object, and that's it, right? So new instance. What we're gonna do is just we're gonna use new instance dot transform dot look at, right? And the look at requires here a vector, right? So we need to say we're gonna be looking at a vector that it's gonna be what? We're gonna provide a vector. We actually could provide 2 vectors, and that's what we're gonna do. We're gonna provide first the vector of the direction we should be looking at, and the vector that it's aiming up, which is gonna be the normal of the face. So let's create those 2. So variable to look is gonna be from the type vector3, and it's equal to P0 minus centroid, right? So we have the centroid P0, that's going to be the, let's imagine that it's this point. It could be any point for that matter, because in this case all kind of, it's a triangle, right? And it's an equilateral triangle, so it doesn't really matter. So a vector between those 2 plus, and here we're going to just we're going to say plus the position of the object, right? Because this vector doesn't really leave. When we create this subtraction, this vector is going to be just a very small vector relative to 0, 0, 0, right? So we want to place that object right in the position, and the variable, let's call it up, also from the type vector3D, is gonna be it's gonna be equal to the normal, right? So the normal, here it is. We could unitize it, but in this case it's fine, it's just not necessary, right? So what we're going to provide to this lookat function, it's the vector to look and the vector up, right? So so let's imagine what this is doing really, or let's try to see if it's working, and if it's not, we just do some changes. We have some problems here, unknown identifier triangles. So let's see there. So there we go. Let's see where the geometry is. There we go. So, okay, this is something's happening, but it's not so precise really, right? So let's look at it. And what's happening right now is that we're kind of placing the orientation. There's some rotation going on, but it's not exactly what we need, right? So let's look at what is our problem here. Right, so I think I've found the problem, and the problem is just a few things really, right? So one of the things here is that this code here, we should be using 1 and 2, right? And I'm going to point out where to find this information. If you look for the hit.triangle index in the documentation file, you can just check some of that, some of the script, right? The other thing we're going to just do here is just add parentheses here, just to make sure that the centroid calculation is being done properly, because we are kind of adding these elements and then that addition just dividing, right? So simple. I forgot to put those parentheses in, right? And the same happens here. Well, if we do it right now, it should be close, but we need to do one more thing. We need to actually, here in the look position, we need to add times -1. We could have just put centroid first, but I mean, this -1 allows us to kind of determine the orientation with a variable, right? If we would want to. So let's see the situation right now. So what we're doing is just hitting up that object, and then you see that we create a tetrahedron that it's just oriented precisely in the face in which we're hitting. And I think my computer is running a bit some problems, but like this should be working pretty well. Yep, so that's pretty good. Just let's look at it again. Important information, just to go through it again. It's getting the information of the face that we're hitting. So we're getting like hitting the face, but we're getting now the points of the edges of that face. In this case, because it's a tetrahedron, it's only one triangle, right? If you're hitting a much more complex object, you realize that those points are definitely more complicated, because it's going to be like a little triangle within a bigger face, right? So something to bear in mind. We are kind of accessing the information of the vertices through this formula that you can find in the documentation of hit.triangle. So let's look at that. Scripting reference, raycast hit. So raycast hit, and then we have triangle index, and then you have this stuff, which is where I actually got it from. It's a script that shows you how to access the information of the points, both in local and global, right? So I just copy paste that, and we could have saved some time really. Just copy pasting that stuff, but still. Then we get the centroid, which is not provided here, but I mean, it's just a simple idea of like adding these 3 points and getting the average of them. So that's the centroid of the face, and we are using that for the look function the look at function, where we kind of rotate the object, and you'll see that what we're doing is like when we, let's try to just analyze that a little bit more. When we click one, I'm going to go to scene mode. In our object, the forward vector is aiming backwards, or like it's against this kind of arrow here of this triangle, right? So we know that the vector forward times -1, it's going to be the direction of this triangle, right? So we want to make that triangle look at the same direction that you would have between the center and this point, right? So in that direction. So that's what we're doing. It's just placing this kind of look at option from the center in the direction of this kind of edge. And we're also determining that this is the vector up, which is the normal of this face. Like the face that we're hitting has a normal, right? So that's the normal that we're using to determine the up vector for this operation, right? With those two pieces of information, the object can only be in this orientation, and it's gonna be consistently located like that. So you can just go crazy and click objects as you want, and you see that and whatever you do, similar to what we were doing with the cube, it's gonna continue happening consistently. So you can just go and build all sorts of geometries like that. So it uses the same principles of Minecraft in the sense of just placing geometries one close to another one and then start building something out of those. And we saw how to also apply some texture, so you can do very much more creative stuff than just these colors. But it's kind of helping you kind of visualize how you would need to orient geometries. Obviously, for each geometry it would be slightly different, but it's when you have a custom geometry like this one that has a kind of a local orientation, it gives you kind of the hints of how you would proceed to actually do it with any other geometry, right? So yeah, that's it for this one, and I'll see you guys soon.